Welcome back to another crash course where we take a topic and break it down to manageable pieces of information that you need to get started with it. So today we're going to be talking about the Git utility, and this is a command line tool very widely used in very many domains of software. It's kind of a must-have in the toolkit of any developer at this point. So this first video here is going to be kind of an introduction as to why and how you'd use this. It's going to be great for anyone who is a complete beginner. You probably should have some sort of experience on the command line and or coding experience using this, but it's not necessarily required. In video number 2 and 3 of this series, we're going to be covering some more intermediate and even advanced topics of Git. So if you'd like to, you can follow along from this video right here all the way to the end. So here are the topics. Let you peruse these at your own will. We're going to be going through pretty much all the basics of Git. So the question we need to answer first off is, why are we using this tool and what is it? Well, on this screen here you're going to see a little bit of a diagram that might not make a whole lot of sense, but Git is basically a tool that is, number one, distributed, meaning for a single Git repository. We'll talk about all this terminology in a minute. For a single Git repository, there can be multiple users and multiple copies of that repository. Just think about a file back before maybe Google Docs, where you can collaborate on a single file. If you just had like a Microsoft Word document, you'd have to basically email that back and forth to collaborate on it. And this has been made possible now by Google Docs, but truly Google Docs is using some version of source control, whether that be Git or SVN or whatever it may be. This tool allows you to create copies of the same file and allow collaboration on it. So that's kind of what I mean by distributed. Now, multi-branch management is going to be a little bit more confusing because we haven't talked about what a branch is. But if you take a look at the screen here, you can see that there's these different lines with the dots on it. So the dots will basically represent what we call a commit, or basically when you press the save button on a normal document, that would be the dot. And the different lines would be different like work streams. So you could have a single user for a single branch, and they could all have their own copy of that branch, and then once they're all done with their work, you bring it all together into a merge, and you've got a single document that has a history of all those changes. So that's kind of the power of Git, but no need to belabor the point. We're going to dig into this later and figure out hands-on how this is used. Our first order of business is to install Git on our computer if we don't already have that installed. It's going to be a little bit different depending on the system you're on. I'll just quickly walk through the commands. You can pick the one that's applicable to you. We'll start off with Windows. That's going to be Choco install, so you're going to use the Chocolatey package manager. And of course, on any system you can always build it from source code, but usually it's easier to use a package manager. On Mac, it's going to be brew install git, pretty easy. And then finally on Linux, it's going to be sudo apt-get install git. Next, we will need to set up some configurations. So go ahead and look at the screen and pick the one that is applicable to your machine. Basically what we're doing here with this whole CRLF thing is CRLF has something to do with line endings, and since Git is a source control tool and it's going to check every single character of every file in your repository, the line endings that are made on different platforms are going to actually be picked up. So these will kind of eliminate any conflicts that you might have with those. Once you've set those configurations up, you can check them in the config file, which you can also edit directly. So that's going to be at the .git config in the home directory. You can see all of the configurations that we've made. Pretty much they all make sense. The only one that I would recommend if you are using Vim like I do is add in this editor equals Vim command, which will set the default commit message editor to Vim rather than, I think it might be Nano or something like that. So go ahead and set that. That's very useful in my mind. The next thing that we're going to do is a little bit advanced, and you're not going to completely understand what it's going to help us with until we actually learn the Git utility, but we need to set it up nevertheless. So just follow along. If you don't get what's going on, that's okay. You can revisit this section after the video if you need to. And that is going to be creating an SSH key. So the way that we connect to a remote repository is by either HTTPS or by SSH. And we're going to go on GitHub here to look at it. And in your GitHub, you will go to your settings. You go to SSH and GPG keys, and you're going to say new SSH key. And when you click that, it's going to ask you to enter a SSH key. And basically what this does is on your local machine, so the computer sitting right in front of you, you're going to have a private and public SSH key generated. And then on GitHub, you're going to have the public version of that private key. So basically when you authenticate with GitHub and push your changes from your local repository up to your GitHub, it's going to check the authenticity of the SSH key in order to do that. So this eliminates the need for us to type in our username and password every single time we want to make a change upstream to our remote repository. Again, we're going to be covering all this terminology in a moment. To create this key, we're going to first enter the home directory, so type cd, and then we will run the sh keygen utility, give it an option T RSA because we want RSA version keys, and press enter. You're going to have to set up the default one, so this ID _RSA, it's going to be very important that you use that exact key because that's what GitHub is going to look for. So all you have to do really is press enter a bunch of times. So I'll press enter. It's going to ask me if I want to overwrite my existing key. I'll press yes, and then it's going to ask for a passphrase. I'll say I don't need to, so I'll press enter again, and it creates the key for me. Now that we have this key created, what we're going to do is print out, so we're going to cat out the public version of the key. So it's going to be in the .ssh folder, and it's going to be under id_rsa.pub. So there's actually a file called id_rsa. That will be your private key. You don't want to expose that to anyone. So we're going to cat out the public key, and it's totally okay that you on the video are seeing this because you don't actually see the private key that is behind this. So we'll copy that, we'll go back into the browser, and we'll paste that directly into the key portion. And what I'm going to type is Ubuntu updated key. When I press enter, it's going to add that SSH key to my keychain. And essentially what that's going to do is tell GitHub that my computer that I'm sitting at right now is authenticated to push and pull to and from GitHub. At this point, we are ready to create our first repository. And throughout this process, I'm going to be kind of explaining all the common terms that you'd find when talking about the Git utility. So we'll start off with the word repository because that's a big one. A repository is just a single container that has a bunch of source code. Now I know we're going in circles here. Source code is basically anything that is going to be part of a bigger software project. So it's just a fancy way of saying all the code in the project. So let's go ahead and create that. If we are in GitHub, we can come up in this right corner and click New Repository. I'll give it a name, so basic Git tutorial, and then some sort of description, video series. We're going to keep it public, and we are not going to initialize it with a README because we're going to do that manually. So all you need to do is type in the name of the repo and click Create. When you create the Git repository, it'll take you to this screen, which shows you how to set it up. So there's about 4 different ways, but really we're only dealing with 2 different options that we can go with. And for learning purposes, we'll go ahead and set that up with both options. So we'll start off with the method of cloning. So the way that we do that is first make sure that you have SSH selected up here rather than HTTPS, because that is the whole reason we set up that SSH key. And then you'll copy this link right here. And we're going to create a directory for this particular repository. And the way that we do that is, I'm just in my home directory right now. We'll just say git clone, and we'll paste in the link that we had just copied. And by default, if we just press enter, it's going to create a directory called basic git tutorial. Now I want to make a custom directory, so I will say basic git tutorial -1. So this will be the first method of setting the repo up. So I press enter, and it says you appear to have cloned an empty repository, which is true. We have not added anything to it. If you cd into it, so basic git tutorial 1, and type lsla, you're going to see nothing in it except for this .git. And this is actually a directory with, it'll eventually have all of our Git objects. So once we add stuff to our repository, it's going to kind of help keep track of that repository in this folder. And that's it. With git clone, you have completely set up your repository. Now, I want to go through a little bit more manual process for learning purposes and kind of understand what this is doing when we're cloning. So let's clear the screen and create another directory. First, let me get out. We'll create another directory called basic git tutorial -2. And then we will enter that tutorial. And what we're going to do is now type git init. And what that is going to do is initialize an empty repository, or in other words, it's going to create that .git folder. Then what we need to do is add what we call a remote. And what I mean by remote is the server that we're going to be pushing and pulling from. You can basically think of this as GitHub, although there are other hosting services like GitLab or Bitbucket, or you could even set up your own on a server with like AWS or Azure or something like that. So when we say remote, just think of anything that's not directly in front of you. It's the computer that is hosting your repository somewhere out in the world of the internet. Now, what we mean when we say local repository is the one that is stored directly on the computer sitting in front of you. So what we're setting up right now is the local repository, but we need to tell the Git utility where our remote repository is at. And if you remember, we had this link here that we had gotten from GitHub. That is the link that we need to tell Git is our remote repository. So the way that we do that is we say git remote add origin and then paste in the link. Now we understand what remote means, we understand what that link is, but what is the origin? Now origin is basically like a default name that we will call this. We could actually call this anything, and it's just going to be the reference to that particular link. So I'll show you what I mean here. When we type git remote -v, it's going to print out the name of the identifier, which we just by default gave it origin, and then the actual link for our fetch, which means when we pull stuff from the remote repository, and then the push, which is when we take our local changes and push that back up to the hosted repository on GitHub. So like I said, you don't have to actually call this origin. You could call this custom origin, and when we type git remote v, you'll see that it added 2 more entries. And so now we could use either the custom origin or the origin to push and pull from this repository. And you'll see what that means when we get into the some of the commands related to this. After doing all those manual steps, we now have the same exact setup as we had when we did the git clone command. So we'll stick in this repository right here, and now it is time to actually learn the basics of Git. So in order to do that, we need to have some files, and I'm just going to create a simple index.html file. So we'll say touch index.html, and then we're going to use the vim utility to add some HTML to this. So let me paste some in there. It's just a basic web page that we're doing. And now that we have added that, we should have Git tracking all of our files. So if we now type git status, you can see that we are on branch master. We'll talk about that a little bit later. No commits yet. We'll also cover that in a second. And here's what we're interested in: the untracked files. Git has automatically detected that we have added a file to our local repository. So in order for us to take that file and add it to what we call the staging area, we can type git add index.html. And when we press enter, you don't see it do anything, but we'll type the git status command again, and now this message reads a little bit differently. It says changes to be committed, and you can see we have a new file in here. So now we took that index.html from our working directory and added it to our staging area. Now in order to what we call commit this to our repository, we have to run the git commit command. And basically what this is going to do is tell Git that we want to create a record of this file at this given point. So this command, the git commit command, is basically like a glorified Control S or save button on a document. The cool thing about it is when we do the git commit, as opposed to a save command, we actually take a little snapshot of the file at this given time that we can always refer back to. So we'll say git commit -m, and then we'll give it a commit message. If you don't do the -m option, it will just take you into Vim if you have it set up that way, as I had shown earlier, and it'll ask you for a commit message. So we'll just say -m, and then we'll say add our first file and press enter. And you see that what happened is we added our first file. It had 1 file changed, 9 insertions, so we had 9 lines, and it is in create mode. So we have made our first commit to this local repository. Now we're not quite done yet, because if we go back to GitHub and refresh this page that we're at, you're going to see that nothing has really happened yet. We're still, GitHub, the host of our repository, our remote repository, has no idea that we've done anything to this yet. Now, to let it know that we have done something, we're going to need to come back here and run one more command. So remember how we did that, we set up those remote paths, and I'm going to actually delete git remote remove custom origin because we don't really need two. So now if we type git remote, we just have this origin. And so what I want to do is I want to say git push. So we're going to take from local and push it out to our remote repository. And we want to say git push origin. So that indicates to Git that we want to use the URL that we had associated with the origin. And then we type master because we want to push this to the master branch of the repository up on GitHub. Bear with me on the whole branch thing. We'll get to it in a due time. You can see that without adding our username or password, we have pushed up to our remote repository thanks to the whole SSH configuration that we had set up earlier. Now, if we go back to GitHub and refresh the screen, you will see that we now have some information in our repository. You can check out the file here. This is what we just added. You see right here is the commit number, so we can click that. It shows you what we had changed in this commit. We can also see that we have only one branch right here. It's called master. That's kind of the default branch that will be created when at the first part of a repository. And we also have a complete history of what is going on. You will also notice that when we type git status again, it's going to say on branch master, nothing to commit, working tree clean. And that just means that we have everything synced up and our working directory, so the folder that we're sitting on in our computer is going to be the same as the staging area, which is going to be the same as the repository. So everything is synced up and clean. We will now create a change on the host. So the remote repository GitHub is another way that we can actually modify our repository. We can do it locally, which is what we did earlier, or we can do it remotely on the host server, which is GitHub. We'll click into index.html and press edit this file. What if we wanted to maybe add some body to this HTML document? We could say this is body text, and there's our change. Not a big change, but it is a change. We'll come down here and we'll say updated index.html from remote host. You don't need to add any optional extended description, and you can see that we have the check mark commit directly to the master branch. We'll commit the changes, and now what just happened is we have our remote repository, which is GitHub, and that is different from our local repository. If we come back to the terminal, you'll see that when we cat out index.html, we don't have that change that we just added. Now, if we wanted to get that change, all we have to do is pull the information from the remote to the local. So this is what we call pulling from upstream. So the upstream is the remote repository, and the downstream is the local repository. So we're going to pull downstream to our local repository by typing git pull origin master. So we're going to connect to the origin URL, and then we're going to pull from the master branch. When we do this, it will show a fast forward, and we have one file changed, and now we can cat out index.html and see that we have this body text right here. So pretty cool. This is the basic workflow and the basic commands of Git. So let me just review. We'll go through one more example to kind of show the workflow that you'll be going through when using Git. So the first step is going to be make changes. So we can create a new file. So new file.txt. We can edit that file. And then what we have to do is, now that we have edited our repository, we have to stage the changes with the git add command. So we can say git add new file.txt, or we can just put a dot to add everything in our repository. Make sure you check it with git status. You see that we have something in our staging area, and then we will commit with a commit message, added a new file. Once we have committed, we will push to our origin master. It pushes to GitHub, and then that is pretty much it. And if you have made changes, or maybe one of your teammates has made changes, you'll always want to start your day off by typing git pull origin master. And right now it's going to say nothing because everything is up to date. So that's the basic workflow. You just do that over and over again. Now I know it sounds very simple at this moment, but when we move into the second and the third videos, you'll see how this can get pretty complex, and you'll run into quite a few problems along the way if you're not careful. So I'd highly recommend you checking out those next two videos. I think you'll get a lot out of it and see the real power of using Git. Welcome to part 2 of the Git crash course. Last tutorial we talked about the very basics of the Git source control tool, and in this video we're going to jump into something a little bit more intermediate, or maybe even advanced, and I'm going to show you a workflow that you can use to develop production ready software. This video is going to be great for anyone who may have already been familiar with Git and just wants to brush up on their skills, or anyone that's working on a team as a developer and has to collaborate with others on a repository. To follow along with this video, you're going to need some basic Git skills. So you're going to have to know how to add, commit, push, pull, all that kind of basic stuff, or just go back and watch the first video in this series. On the screen are the topics listed, although these are going to be a byproduct of the workflow that I'm going to show you, which is on the screen right here. I'm not going to try to spend the time explaining what this diagram means. If you want, you can pause the video and take a quick look at it. But essentially what's happening here is we are creating feature branches from the develop branch, which is considered like the main development branch that we're working on, and we are going to do work on that feature, commit it, and eventually merge it back into the develop branch, which will then eventually be merged into the master branch, tagged as a release, and then you will start the workflow over and over again. Now, it doesn't make sense yet because we don't really know what a branch is, or how to check out a branch, how to create one. But I think the easiest way to do so is to just get started and go through a practical example and actually build out a repository. I will start off by creating a repository. We'll name it Basic Git Workflow, and I will click Create. Once we have this, copy the URL or the SSH URL, and then come back to the terminal where we will actually get this set up. I'll make a directory called Git Workflow, cd into it, and type git init to initialize our repo. We will then say git remote add origin and copy in the URL that we just saw on GitHub. So this will connect our repository up, and then finally we're going to create a few files. And once we've done that, we have enough to make our first commit. So we will go in there and add the files. You can do this by typing in both of the files, or you can just type dot to add them all. You can check them with git status. You see that we have 2 in the staging area, which we will now commit as our first commit to the repository. And finally, we are going to push that up to the master branch of our repository on GitHub. And when we do that and come back to GitHub, refresh the screen, you'll see that we have one commit with these 2 files. Alright, so pretty simple. The last thing that we need to do is set up a license for this repository. So we will touch license, and then what we're going to do is open that up with Vim and copy in the following contents. If you were to use this repository, you would just add your name under the copyright here. That's how an MIT license works. So you would come up here and actually type the same thing, so copyright 2019 or whenever you're viewing this, and then your name. So that's how you would use an MIT license correctly. So we'll save that, get out of there, and then add this license. We're just doing this so that we have a couple commits to work with at the beginning. We will commit this, add license, if I can type, and then we'll push that up to the master branch as well. I know we haven't actually done all that much work yet, but for our sake of learning, we are going to consider the work that we've done the first production release for this repository. So it's definitely not a production release, it's not even useful software, but we'll go with that just to demonstrate this workflow that we're trying to get at. So we have already committed 2 commits, and say that we wanted to tag that second commit as the first production release. To do that, we're going to have to first see what tags are in our repository already. So you just type git tag, and you'll see that there's nothing there, which is something that we would expect given that we haven't tagged anything yet. To actually tag this first production release, what we'll type is git tag, A for annotated tag, which allows us to type in version 1.0 as the marker for it. And then we'll type in a message, added the first tag. And what this will do, since we didn't specify any particular commit to tag, it's going to tag the most recent commit, which is the one that we would want. Now we can also show this tag, so by typing git show, and it'll show all the things that are in this particular tag. And you can see that we have the license, and that's what was on the latest commit. Alright, so we have the first tag, and now we can type git tag and see version 1.0. Now to push this up to our repository, since we didn't actually add new files, we can type the git push and then type in the tags flag and then type origin master. And that will push it up to the master branch at our remote repository, which if we flip over there and refresh, you'll see that we added the license, and then you will also see in the tag section we have this version 1.0. So that indicates that this was a successful push of that particular tag. Alright, we've created our first tag, and now we're going to create our first branch. Now, as we'd spoken about earlier with the diagram, we want to have a master branch that will be kind of our production releases only. So we're only going to push code that we consider production up to the master branch. And we'll do all of our developing on some other branches, namely the develop branch and then a multitude of feature branches. We'll get into the feature branches a little bit later. To create this develop branch, all we need to do is type git branch develop. And if we pressed enter, it would create the develop branch. Before I do that, I want to show you a command that you can use with Git that will help you understand what is going on in your repository. So that command is git log, and you can type it git log, which will print out everything, including my email address, which I'm not so interested in doing. Or you could type out a longer version of that command, which says git log, one line, decorate, graph all. This will print out one line for each commit. It will decorate it, highlight it with different colors, and it'll put it in a graph. So as we start to branch out and merge changes into branches, you'll see how this works. And then this last part says all, just meaning that we're going to print out all the branches, not just the current branch that we're on. So you can press enter, and you will see the history of this repository. Now, one tip, I would put this into an alias. So if you go into your profile, this is where you would put your alias, and I can type glog and get the same result. So it's a much quicker way than trying to type out and remember all of these options. So that's just a quick tip. All right, so we type glog, and this is going to show us the history of our repo. In this output, I wanted to point out three things. So on the right, you'll have the commit message. On the left, you'll have the commit hash, which has obviously been abbreviated. So you'll just see the first 7 characters, and that will represent the whole commit. And then third is this little parentheses right here, which basically shows you that the head pointer is pointing at the master branch. It has a tag of version 1.0, and it represents the origin master on the remote repository. Now, we're going to learn about this in just a moment, but first, let's go ahead and create that new branch. So if we type git branch develop and press enter, you can see that nothing has really been output, but if we type git branch, you'll see that we now have 2 branches in our repository. Notice that the star is still on the master branch, and that is because we haven't switched over to our new develop branch yet. And we can see this represented in the presentation. So you'll have the first commit, the second commit, which has the version 1.0 tag. And then the more interesting thing about this is all the stuff going on around these commits. So in Git, it's very important to understand this pointer right here called head. And the reason being is because the head pointer tells us where the Git repository is currently pointing. And as you can see here, we are pointing the head pointer at the master branch pointer, which subsequently is pointing at the most recent commit in our repository. As we had seen a little bit earlier, we had created this new develop branch, but we haven't actually checked it out yet, which basically means that the head pointer is still going to point at the master branch, which points at the most recent commit. The develop branch also points at that recent commit, but we won't be able to work on it until we actually check it out. So let's go back to the terminal, and the first thing that we'll do before checking out this branch, and when I say checking out, I just mean switching over to it. The first thing we'll do is type git status. And the reason that we have to do this is because if there's anything in our working directory that doesn't match the repository or the staging area, it's going to prevent us from actually switching branches, because Git is designed to lose the least amount of work possible, and it kind of protects against losing any work through this mechanism. So we have a working tree that is clean, so we can check out the develop branch. And when we do that, it says we have switched to develop, and if we go back to our presentation and switch to the next slide, you'll see that this head pointer has actually flipped from the top, pointing at the master branch pointer, and now it's pointing at develop. And that just means that we're pointing the head at develop, which is pointed at the latest commit, and therefore we have checked out the develop branch and we can work on it. If we come back to the terminal and type git branch, you will also see this reflected. We have the star pointed to the develop branch. If we wanted to actually make some changes to this develop branch, now that we're actually switched to it or checked out to the develop branch, we can start editing our working directory. So I will create, actually we're not going to create, we're going to edit the index.html file. So at the moment it looks pretty awful, and it's just basically a long string of HTML. Obviously, if we were actually coding this, we would make this a little bit more formatted. So that's what I'm going to do here. I'm going to basically just delete all this, and then we'll copy in an amended version. This form of HTML is a lot cleaner, and you can also see we've got this CSS in here and a few more tags at the bottom. So we'll save and quit, and then what we can do is add this to the develop branch. And it is as easy as just adding index.html. We don't have to do anything special. Then we can commit something, so add CSS to HTML. And then finally we can say git push origin, and then instead of master, so this would be pushing to the master branch, we'll reverse that and we'll say develop branch. So we're going to be pushing that commit to the develop branch. Let's run our glog command, which is just the git log with all those options that I showed earlier. And you'll see that we now have the head pointing at develop, and we have this latest commit here, which is 37CE749. Let's go back to the presentation and see what our repository looks like now. You can see that we have 3 commits, and the develop branch is pointing at the most recent commit, and the head pointer down here is pointing at the develop branch. So therefore, the head, or where we're working in the repository, is at the latest commit, but the master branch up here is actually a commit behind. So if we wanted to catch that up, what we would do is called a fast forward. You'll see this a little later on when we finally kind of merge the develop branch into the master branch. Let's make a few more changes to this repository, and we are going to eventually make our second release for this, whatever software project that we're making. So the first thing we'll do is we'll go into the index.html file, and we're just going to get rid of the style stuff. We're going to add the CSS to a separate file, so we will refer to that in the HTML as style.css. And then I think we can keep the rest of this the same. So let's save and quit. And then what we'll do is create a style.css file. And remember, we are still on the develop branch, so all of these files, even the file that we just created, is not going to be present on the master branch quite yet. So we'll put in the style.css content, and this is going to connect up with our HTML document, and we can finally stage and commit our changes. So we'll just type git add dot for all, and when we type git status, you should see in the staging area we have these 2 files that one of them is a new file and one is modified. We will commit this to our develop branch, so split HTML and CSS, and then finally we will push to the develop branch. We can print out the history or the log of the Git repository and see we have this new commit hash here, and we can look at this over in the presentation to see that we now have a 4th commit, and once again the develop branch will be pointing at that commit, and the head pointer will be pointing at the develop branch. So therefore we are currently at this latest commit. The next thing that we're going to do is not add anything more to our develop branch, but actually create a new branch called feature 1. So this is going to be our first feature branch, and is kind of part of the workflow where, say you've got a couple people working on the develop branch at once, and therefore you're going to, if you want to make any changes without messing with other people's code, you're going to have to create a new branch based on the develop branch and call it some sort of feature, and then you work on that and eventually merge it back into the develop branch. To create the feature, we'll first look and see what branches we have, make sure that we just have these two, and then we will type git branch and then feature 1. So I just say feat 1 for brevity. We created the feature branch, and now we want to check our status. We have nothing to commit, the working tree is clean, so therefore we can check out the feature 1 branch. Now that we have this feature branch checked out, let's go ahead and add some JavaScript to our HTML file. The way that we'll do that is by first adding the tag to the end of the body. So go down here. We don't want to do that. Let's see. And then we will add a script in here with a source of .script.js. And that is all we need to do to add it to the HTML. We also need to create script.js and put the following contents in that script. For anyone actually interested in what the code is doing, you don't really need to be. Basically what this is going to do is kind of flash the header that's in our HTML file. So if you're following along and actually running this HTML, that's what this is going to do. Nevertheless, let's save that and quit. And then finally, we will update our CSS file one more time to have a few more changes. So we need to add this little hidden class at the bottom to allow our JavaScript to work correctly. And once we've done that, we should be good. So we will now add everything to our feature branch staging area. If we type git status, you'll see that we have these 3 files, 2 that were modified, 1 that was created new. And then finally, what we can do is add this or commit this to our feature branch. We have committed this, and we will now push to the feature 1 branch instead of develop. We created a feature branch and we added some what we think is super complex JavaScript. We're just patting ourselves on the back. And then we realize, wait a second, we forgot to add a gitignore to our file or to our repository. So we'll go back to our develop branch. So we git checkout develop, and then we will create some sort of to-do list.text, and in this to-do list maybe we'll say write awesome code, and that's our only to-do for the day. The reason that I created that is basically just to demonstrate what the gitignore file is going to do for anyone watching this video that is not so aware. And when we create this gitignore file in the root of the repository, it's going to tell Git which files that we don't need to keep track of and basically ignore. So we create this gitignore. Remember, we're in the develop branch. We switched from the feature branch. And in this gitignore, we're going to echo in to-do list.text. So that's basically going to ignore the to-do list file from our repository, and then we are going to add everything. And then when we type git status, you'll see that we have a new file .gitignore, but it doesn't show the to-do list.text, and that's because we put that file in the .gitignore and asked Git to kind of just forget about it. So we have added this file here, and what we want to do is actually commit it. And then finally we will push to the develop branch. So since the last time we kind of looked back at our repository and put it in a diagram, we've made several changes. So we changed the index.html file, and we added a JavaScript file, and we even added some new CSS. That was all done on the feature 1 branch. We then forgot about the gitignore file. We said, hey, we want to actually add that to the develop branch. It's a day later. We're not thinking about the feature branch anymore. So we come over to develop and we add the gitignore file. We commit that file, and so now we have one commit on our feature one branch and one commit on our develop branch. If we type that fancy command, I'll just repeat it. I won't do the glog for this one. I'll actually copy in the full command here so that you can see it. And now you'll see that this little decorate and graph coming into action, because you'll see right here there's kind of like a split going on in our repository. Instead of looking at this little tree that we have, although this is basically what you're going to be doing once you're on your own, we'll go over to a diagram that I've put together that kind of shows this repository in a more visual way. So you'll see our master branch is still at the first release. We haven't made any changes to it in the past couple commits. And so we have all these commits, and finally we have these two commits that are basically diverging. So this DEB FAE4 commit is actually going to be the parent commit for both of these commits that we just made. So the first one is the JavaScript feature. So this is going to be the update to the index.html, the update to the style.css, and the creation of the JavaScript or whatever it's called, script.js. So we've changed 3 files in this commit, and then that's on feature 1 branch. So you can see that feature 1 branch pointer is pointing at that commit. And then you see down here, the develop branch is pointing at the commit where we added the .gitignore file. You can also see that the head pointer is pointing at develop, which just means that we're currently sitting on the develop branch. Let's hop back into the terminal and just kind of see what's going on here. So remember, we have the 266 commit is going to be the JavaScript feature, and the 740 is going to be the .gitignore file. So we pop back into the terminal, and what we're going to find out is that currently we are sitting on the develop branch, and therefore the files in this branch are not going to match this JavaScript feature that we added. So notice we don't have anything that resembles a JavaScript file, and if we cat out the index.html, we don't see anything down in the body that links up to a JavaScript file. So clearly we don't have those changes there, but what we do have, if we print out hidden files, is this gitignore file. And that makes sense because we added that to the develop branch. Now let's type git status. You can see that we're on branch develop, nothing to commit, working tree clean, so we can check out the feature 1 branch. Once we check this feature 1 branch out, you'll start to see we actually have the script.js here. So this is the JavaScript file that we made. And if we cat out the index.html, you'll see that we have the script tag added at the bottom of the body. So basically what I'm trying to say is we have these 2 different commits on 2 different branches. And so basically these branches have completely different snapshots of our repository. Now the goal is going to be, we want this feature branch to merge back into the develop branch. Since the changes that we made on the feature 1 branch and the develop branch are not going to conflict, so we didn't edit like the same parts of a single file, we can merge them pretty cleanly together. And the way that we merge something together is by first checking out the branch that we want to merge into, and then typing the git merge command followed by the name of the branch that we want to bring into the branch that we're currently checked out on. I know it's a little bit of a mouthful, but you'll see what I mean in a second. So let's first check out the develop branch, and from here what we can do is type git merge and then feature 1. And what this is going to do is take all of those changes from feature 1 branch and pull them in to our develop branch. In other words, once we have this merged, our develop branch is going to show the script.js it'll have the updated style.css, the updated index.html, and the .gitignore that was originally edited on the develop branch. So we'll press enter, and it's going to pop us into a message, and we can edit this message however we want. I don't really care to change it, so I'm going to save and quit from Vim. And you'll see that we said the merge was made by the recursive strategy. And we have these 3 files from the feature branch. And you will notice that there's no .gitignore here because that was already on the branch that we're merging into. So let's clear the screen and type ls to see that we now have script.js, and to confirm we are on the develop branch right here. So the last step after we've merged files from the feature1 branch into develop is to delete the feature1 branch because we don't actually need it any longer. The way that we do that is by typing git branch and then give it the -d flag and type feature1. And what this will do is actually completely delete the feature branch. It says deleted branch, and it was on this commit. To see what's going on in our repo, we'll once again type the git log command, and when we see the output here, we're going to notice that this branch has actually kind of merged back in to the develop branch. So these are the 2 commits right here that we had merged together into the develop branch, and you can see that this is the JavaScript stuff and this is the .gitignore, which eventually merges together into the develop branch at commit CE60A9B. Let's hop into the PowerPoint again and just visualize this a little bit easier. So once again, master branch is still way back there. Eventually we're going to merge develop into master and they'll be the same, but for now that's kind of sitting way back in time and it's only got a couple files. You'll see here are our 2 commits where we have the JavaScript feature and the gitignore file, and then this commit right here, which is the latest commit that we're currently on, hence the head pointer that's pointing at the develop pointer, which is pointing at this commit. That brings these 2 changes or commits into one commit on the develop branch. Now the last thing that we want to do is take all the information here, what we call a snapshot or a commit, and we want to take all this information and merge it into the master branch. Now it's going to be a little bit different than this merge here, because in this merge we actually had 2 commits that were coming from the same parent commit. Now in this case the master branch is sitting way back in time and it actually has no divergence. So basically what we're going to be doing is taking the pointer for the master branch that's currently pointing at this commit right here, and we're just going to march it all the way up the repository and point it at this last commit right here. So we're not actually doing like truly a merge, it's basically moving the pointer to the latest commit. Let's go into the terminal and do that really quickly. The first thing that we need to do is once again type git status, make sure that we have a clean working tree, and then after that has been checked we will move over to the master branch. So we are now on our master branch, which is where we will do all of our production releases, and the way that we merge, as I just explained, the develop into master is by typing git merge develop. And that's going to bring develop into the master branch that we're currently on. You'll see that we fast forwarded, and the reason that it says fast forward is we're basically taking that pointer, the master branch pointer, and walking it up the commit line to the latest commit. So now if we type the glog, you can see that the head is pointing at master and develop because they're actually at the same exact spot. The last thing that we need to do, since we officially released our production code, is tag the commit that is the most recent one on the master branch. So remember, we are still on the master branch, and we can write this tag, so version 1.1, and we have officially tagged the latest commit on the master branch. We can now jump back into the presentation and see the final state of our repository. So as you can see, the only thing that changed is we took this master branch and we originally had it pointed at this commit right here, version 1.0, but we basically moved that pointer up the repo and pointed it at the latest commit in the repo. And then finally, we pointed the head pointer at the master branch. So basically, we're currently working on the master branch. And the reason that we saw this in parentheses here, head is pointing at master and then comma develop, is because the develop branch is going to be pointing at that latest commit as well. So develop branch pointing at that commit as well as the master branch. And that is pretty much it. That is the basic Git workflow. So to recap, basically all we did was we created a master branch and a develop branch. We did some work on that develop branch. We maybe created a couple feature branches, merged those into the develop branch, and eventually when we were ready to release our production code, we merged the develop branch into the master branch. So this is basically the workflow that even pretty complex projects from big companies will use. I will say that there are a couple extra branches that many companies are going to use to manage their source code. That could be things like hotfixes. There might actually be a branch dedicated solely to preparing a new release to go out into production. But in essence, we are looking at a professional Git workflow, and you can just go through this over and over again, releasing, version 1.0, 1.1, 1.2, and use this for pretty much any project that you would ever need. This is part 3 of a 3-part series on the Git source control tool. In videos 1 through 2, we talked about the basics of Git and an effective Git workflow for you or maybe even your team to develop production-ready software. But we had one really big issue with those last 2 videos, and that is the fact that we had no problems to deal with along the way. We pretty much assumed perfect conditions. We assumed that everyone on our team was working perfectly in tandem, and there was no conflicts going on at any point with our repository. Now, this is far from a realistic scenario, and in real life, you're going to run into plenty of problems with the Git source control tool. And half the battle is knowing how to resolve those problems without having to pretty much reset the entire repository. So this video is going to be perfect for anyone who is either working on a team, or maybe you're like myself and you finally got tired of not understanding what the Git Reset, the Git Checkout, and the Git Revert commands do. So these 3 commands are all commands relating to kind of troubleshooting your repository and switching between branches in your repository. So you'll learn in this video a deep dive of those commands, and you'll finally understand, how do we actually resolve conflicts in our repository. Now, this has 2 prerequisites. That would be video number 1 and number 2. If you're already a little bit familiar with Git as a source control tool, you just need to watch video number 2 because we're going to be continuing with that repository in this video and working off of it. We'll be covering a variety of topics, but pretty much the main ones would be the Git Checkout, Revert, and Reset commands, as well as an overview of the 3 trees concept that you might hear every so often. We'll start off by addressing one of the most common problems that you might face when working with Git, and that is a conflict between your remote repository and your local repository. In order to demonstrate this, I'm going to jump into the repository that we've been working in the last video, and I've actually signed in with a different user. So you can see at the top right corner, I've got some test user that I just created, and I've actually given this test user access to modify the repository that we've been working in. So I'll create an intentional merge conflict in the README document. So let me click into README, edit this file, and then we're going to put in a line of text here at the end that should create some sort of merge conflict. So I'll paste that in here. This line was added by another contributor. It'll create a merge conflict. And then for our commit message, we'll say create intentional merge conflict. And we don't need an optional description. We'll just commit the changes. And as you see, we now have 2 contributors to our repository, and the test user for our tutorial has been one of those contributors. Now let's jump into the terminal and make a change locally. So if we type git status, we're on branch master, nothing to commit, working tree clean, and so therefore we can come into the README document, the one that we just edited with the test user, and put in a local edit that's going to conflict with the one that we just did with the test user. Let me get rid of this character at the beginning. We'll save and we will quit. So at this point we have a conflict. The README up on the remote repository is going to be different. It has different contents than the one in our local repository. So if we were to try to pull in the changes from the master branch, we're going to find that we have a little bit of a conflict. It says, please commit your changes or stash them before you merge. And then it says it is aborting, which basically means you've got to manually fix this conflict before Git can actually bring in those changes. And in this scenario, we have 3 options. The first option is that we could commit our changes as the message had mentioned. So we could, add the README and then commit those changes and then pull in the changes from the remote repository. But the problem with that is we'll just be overwriting our local changes if we do that. Now our second option is we could actually reset everything. So we could type this command, git reset hard flag, and then head. We'll learn about this command in due time, but basically all this will do is bring back our changes locally to the previous commit. We're not going to do that because we need to learn what the git stash command is. And what this does is it will take all of those changes that are in our working directory and just kind of stash them away for a minute. So we'll type git stash, and it says it saved the working directory, and index state WIP on master. So there's a bunch of information here. We don't really care too much about it. What we care about is that we can now pull in the changes from the remote repository. So it'll say merge branch master, and we'll just say OK, save and quit. And you can see that we have actually merged in the changes successfully. Alright, so we've got these merged in. Now, what if we wanted to get those stash changes back? We had, let's see what the README looks like right now. And you can see that it currently reflects what we did on the remote repository, and it has no recollection of the changes we made locally. If we wanted to get those changes back, we can actually get the stash back and commit that in. So first we'll type git stash list, and that's going to show us all of our stash changes that we've made. You'll see that we just have one here, and it's represented by this little symbol. And if we type git stash apply and then give it that name, so stash at, and then the little brackets 0, when we press enter, what it's going to do is look at those stash changes, take those changes, and overwrite our current repository with those changes. Let me press enter. You'll see that we have a merge conflict, but this should be okay. Let's cat out the README, and we now see that there is a few extra lines of text within this file. We need to go into the README document and resolve this merge conflict. And all we need to do to resolve it is delete this line, delete that line, this one, and this one. So now we have our stash changes, and we can save and exit, and then we'll type git status. We have something modified, so we can add that, and then finally we can commit overwrite local with stashed changes. And then we can finally push that to the remote repository, and we have successfully taken those stash changes and overwritten what we had pulled in from the remote repository. Now you might have noticed that the second time around, when we went to apply our stash changes in the local repository, we actually had a little bit different process. So when we pulled our changes from the remote, it didn't ask us to resolve any merge conflicts. And that is because this is a slightly different conflict that we're dealing with. So before, we looked at a conflict between the remote repository and the local. And in this second case, we were looking at a conflict between just the local repository. I'm going to demonstrate this again, but this time around we're going to use the Visual Studio Code editor to resolve this merge conflict. And I just wanted to introduce this because I know a lot of people work in Visual Studio Code. It's free, it's an awesome text editor, and I work in it myself, so I wanted to leverage the capabilities of it and kind of show you how easy it is to resolve conflicts in it. First, we need to create a conflict. So what we're going to do, let's type in git status. We've got a clean repository, so that's good. Always want to check that first. And now what we're going to do is create a merge conflict branch. So if you remember from the last video, this is the command we use to create a new branch. And then the checkout command, which we'll explore a little bit more later, is going to be how we actually switch over to that branch. So at the moment, we can see that our README file has the following text. So we need to edit this using Vim, and instead of that line, we're going to say I made this change from the merge conflict branch, if I can type. Currently, if we were to try to merge the conflict branch into the master branch, it's actually going to be okay. And although the contents of the README is different, we haven't actually made any change in the master branch. So what it's going to assume is that we just want to overwrite the changes from the master branch with the incoming, merge conflict branch. If we really want a conflict, we need to make a change to the README in the master branch. So as you can see, we've already checked that out. We're on the master branch. So all we need to do is go in Vim and make some sort of edit. Let's just say some conflicting text from master branch. And we'll save and quit. We will add those changes, commit them, and we are finally ready to actually merge them in together and fix the conflict. So we'll type git merge conflict branch. And so remember, we are on the master branch right now, and so therefore whenever we type git merge, it's going to bring in whatever branch we're specifying into the current branch that we're on. So I'll press enter, and it'll say auto merging conflict automatic merge failed. So this means that we have to manually resolve those and commit them on our own. And in this case, we're going to use Visual Studio Code to do so. We are now in Visual Studio Code, and to get to this merge conflict, we can either click on the file that we know is the actual conflict, we know that it's the README, or we can come over here to the source control tool, and it'll show some merge changes that we need to address. So we can double click the README to open it up, and you'll see that we get this nice little highlighted area which basically lays out what the incoming commit is going to be. So the text that we made in the merge conflict branch, and what the current change is, in other words, what we made changes to in the master branch. So we can accept the current change, the incoming change, both, or compare changes. In this case, we just want to accept maybe the incoming change, doesn't really matter. And when we do this, it's going to delete the current change and pretty much resolve the merge conflict for you. So right there, we resolved the conflict. We'll Control S to save the file. And then we have 2 steps left, pretty easy. Come over here and press this plus button to stage the changes. This is the equivalent of running the git add command. So press that. We've staged it, and then finally click this check mark up here to commit the change, and we can say resolve merge conflict, and that will be our commit message when we press enter. So we pressed enter, and everything has been committed, and we now have resolved that merge conflict. So this is just how you would use Visual Studio Code, and the real power of this comes in when you have multiple merge conflicts. Maybe you have 10 different files that you have to resolve. It's really easy to just click this little source control tool and then look at all the files that you need to address and just start clicking through them and, accept the changes that you want. So that's just a really neat tool that I thought would be useful to show, and hopefully you got a little bit out of it. To this point, we have covered how to fix a merge conflict, and that is a huge sigh of relief to a lot of people, including my previous self. I had a pretty hard time with this whole concept. I thought it was so much harder than it actually was, and every time I had a merge conflict, I thought it was the end of the world. I had to restart the whole repository, and it was just a mess. So hopefully that helps you kind of feel a little bit more comfortable using Git. The next couple commands that we're talking about, the Git Checkout, Git Revert, and Git Reset commands, they all have something to do with kind of moving around in your repository and editing the current state of it. Now, these commands are very similar, and you can actually, we'll come to the Stack Overflow post that I stumbled upon that I think explains it pretty well. And there's actually a comment down here, I put a like on it. It says, lead pipes, daggers, and rope can all be used to murder people, but that doesn't mean any of those things are particularly similar. And that's a pretty good analogy for these 3 commands, because they definitely can do similar things, but there are some specific situations that one is going to be better than another. And I'm going to show you which situations warrant which command. But first, we need to understand something called the 3 trees. And if you type this into Google, this is what you're going to find. The 3 trees of Git are head, index, and working directory. Now, what does that mean? Well, before we try to explain all of that, I think that we'd be better off to look at these 3 trees with a little bit different terminology. And that is the repo, staging area, and working directory. This is a little bit more simple to conceptualize, and it's more in line with what we've been learning throughout the last video. So basically, these 3 trees can have 4 different states at any given time. You can have all of them equal to each other, all of them not equal to each other, and then some sort of combination here. I know this doesn't make any sense right now, so we're going to jump into the terminal to recreate what these 4 states represent. The first state that we'll find ourselves in is state number 1, and this is kind of the one that you're always going to be seeking, and you definitely want to make sure that you're in state number 1 before you go running a bunch of commands. So if we write git status, you'll see this message that we're pretty familiar with at this point. It says nothing to commit, working tree is clean. This is always going to indicate to you that you are in state number 1, or in other words, the working directory, the staging area, and the repository are all going to be synced up. So that is state number 1. Now, what if we wanted to create a different state? We can do this by creating a new file. So we'll type 3trees.txt, and we don't really need to put anything in that file right now. All we need to do is type git status again, and this time you'll see that we have an untracked file. So at the moment we have a divergence between the working directory and the staging area. So we'll go back to our slideshow here for a moment and look at the current state that we're in. So we're definitely not in state number 1 because we had already looked at that. Now let's go to state number 2. It says repo is equal to staging, but staging and repo are not equal to working. And that fits the bill pretty well because the working directory has this new file that we haven't quite added to, the knowledge of the Git tool, and the repo and staging are going to be similar. So we are now in state number 2. Alright, so we'll come back to the terminal and type git add 3trees.txt. Once we do this, we'll type git status again, and now you can see that the Git utility has picked up on this new file, and it realizes that we have added it to the repository. Now we haven't yet committed to the repository, so basically right now our working directory is synced up with our staging area. In this little area right here under the changes to be committed, that is essentially what we call the staging area. So go back to our PowerPoint once again, and you see we're not in state number 1 nor number 2, we are in state number 3. So staging and working are equal, and the repo is the only thing that is different. So finally we will come back to the terminal, and what we can do is commit and add some message, and once we commit that, then we're going to be thrown back to state number 1 where everything is synced up. I'm not ready to commit this change just quite yet because I want to throw us into state number 4 and demonstrate how we could have all 3 of these trees unequal to each other. And the way that we do that is by just creating an additional file. So we'll say additional file.txt, and then we'll put some random text in there. And at this point we have state number 4. Now, how do we tell that we are in state number 4? Well, we can clear the screen and type git status, and now you can see that the staging area, where we see changes to be committed, that is the staging area, has 1 file in it, and then the untracked files, which represents the working directory, has this additional file. And neither of these files are in the repository. So in other words, we have state number 4 where nothing is equal to each other. Finally, we can add the additional file, clear the screen, commit that, and then finally we are back to state number 1 where our git status returns that the working tree is clean. As we move along through the rest of the commands, I want you to always keep at the top of your mind what state you are in. So I know it's going to be a little bit tough since you just learned it. I'll try to point it out as we go along, but what state you are in will affect the commands we're about to run pretty dramatically. So it's important that you always keep in mind what current state we're at. Now the first command we're going to be looking at is the checkout command. So we've already covered this a little bit. I just wanted to show you a few subtleties and show you more conceptually what's going on when you check out a different branch or commit. The first thing that we'll do is start to get used to using the git log utility, because you're not always going to have someone putting together a PowerPoint to visualize what a repository looks like at a given point in time. So you can type this command here, the git log and then all these little options, and this will show you what your repository looks like at any given moment. You can see that our repository is pretty complex. We've made quite a few changes at this point, and you can just press spacebar to go down to the end. What we're going to look for in this particular scenario is where the develop branch is at. And you can see the develop branch is back at the version 1.1 release or commit CE60A9B. So we want to go back to that particular commit or the develop branch. The way that we'll check out the develop branch is by typing Git Checkout Develop. And you already know this, but let's remember what state we're in. So currently we should be in state number 1, which is good. That's where we want to be when we're about to run the Git Checkout command. So we'll check out the develop branch. And what we just did was we switched the head pointer to point at the develop branch pointer, which points at the version 1.1 release. And if we run this log command again and take off this last flag that says all, it'll only print the history of the develop branch. You'll see it's a lot less for us to look at, which is really useful. And we can see that the head is now pointing at develop, which is the latest commit on that branch. You'll also notice that we are still in state number 1. So if we type git status, we're on the branch develop and we're in state number 1, everything is synced up. So although we changed the head pointer, we didn't actually change anything about the repo or the working directory or the staging area. Now, what if we wanted to maybe check out the first commit in this entire repository, or at least the first commit of the develop branch? That would be the 1BD0634 commit, and I just know for a fact that this was the first commit of the entire repository. So if we wanted to check that out, it would be as easy as copy and pasting this abbreviated commit hash into the Git Checkout command. So we'll first make sure that we are in state number 1, as we always do, and then we can type Git Checkout and then paste in the abbreviated commit hash. It'll say we are now checking out this commit, and you'll get this message that says that we are in the detached head state. Now, what does this mean? Basically just means that the head pointer is no longer pointing at a particular branch, it's pointing at a lone commit. And this is basically telling us that if we want to work on anything from this point in time, we need to first create a branch that we can commit the changes to. We're not all that interested in doing this, so let's just take a quick look at what our repository looks like visually. So I'll go back to the PowerPoint, and you can see that we were originally pointing head at the develop branch, and then we checked out this first commit. And so basically what happened is the head got moved over to the first commit, and we're no longer pointing at any of the branches in the repository. We will now talk about the Git Revert command. This is one of the more challenging commands in Git, but once you understand the concept behind what it's doing, it's not actually that complicated. It's basically, you can think of it as like a big undo button. And the feature about the Git Revert command is it's not only an undo button, but you can undo the undo that you just did. So in other words, we're actually going to commit a brand new commit in our repository to reflect the undo that you had just done. I know I'm kind of talking in circles, so let's jump into it and you'll kind of start to see what I'm talking about. So for this example, I've created a brand new repository that mirrors the repository we've been working in. If you log out the contents of it, you'll see that it's just a lot more simplified. We have our first release at tag version 1.0. We made a commit where we added CSS to the HTML. Then we branched out into feature 1 branch and develop branch and worked on some stuff. eventually merge those two together into the merge commit, then we made two commits here later that were useless and will eventually kind of either revert back from or delete entirely. I think it'll be easiest if we look at this in the visual again, and this is where we start to understand what I was talking about with all this undo of the undo. So basically, if we wanted to revert back to the commit 6EFFC40, which is the commit previous to the one that we're currently on, all we're going to do is take the snapshot of files that were in this commit and kind of push them forward into a new commit that will reflect those changes. So in effect, what's happening is we are effectively deleting, we're not really deleting, but we're deleting this A9B commit, and we're going back to this 6EFF commit, but all the while we are keeping the history that we had previously. So if we really wanted to go back to this A9B commit after the revert, we definitely could, and so therefore we're not actually losing any of our files. So again, this is very useful if you're working on a team and you wanted to go back to a point in time without actually, overwriting any of your team members' work. For this command, we're going to go through two separate reversions. The first one is going to be a reversion to the most previous commit, and the second one is going to be a reversion to this merge commit, which will be a little bit tricky because we have to take a few extra steps. So let's first start off with the easy reversion, and that is to the previous commit. The first thing we'll do is use this command. You can kind of copy what I've written here into your terminal. This is a command that I kind of formatted before I started the video so that we can see an individual commit a little bit cleaner. So in this case, I want to see what was in commit 6EFFC40. And when we press enter, you'll see that we have a hash of 6EFF, whatever. The commit message was the first useless commit, and basically all I did was added this useless file 1.txt. So that's all that was happening in that commit, and then we can also look at this most recent commit. So let me give us some room here and replace that commit hash, and now we can see that we added another useless commit and we added another useless file. So basically the effect of this first reversion is we're going to get rid of the most recent commit, and that would be another file.txt. If we print the contents of the working directory, you'll see that we have another file.txt. We can now revert back, so let me first show us the diagram of our repository. So we're going to revert back to this commit right here and effectively delete the A9B commit. To do that, we'll type git revert head. And what this represents, what head represents in this case, is the most recent commit. So that would be 6EFF. We could also tack on a little tilde, which would be the second most recent commit. We could add another one for the third most recent commit, so on and so forth. Another option we have is to just take the commit that we want to revert back to and enter that in there. So we'll use the first option. We'll just use head, and when we press enter, we're going to get a reversion message. We'll just accept that, and then you can now see that we have a little bit different repository. Previously we were right here, and now we've created an entirely brand new commit, 1100, that has the snapshot of the files at the first useless commit, but it's pulled it forward in time. What I'm now going to do is run the Git Reset command. We haven't learned this yet, so don't worry about what this means. I'm basically just undoing what we just did with the revert, so I'm actually deleting that revert commit completely. The way that I do that is the git reset hard and then copy in this commit that we want to go back to. So I'll press enter, And now if we logged out, you see we're back where we started at this add another useless commit, and we have no history of doing the reversion. Once again, don't worry about that. I'll explain it in a few minutes. The second reversion that we're going to do is revert back to this develop branch where we merged feature 1 into develop. So we've got these useless commits and we have no reason to keep them in the history of our repository. We basically just want to revert back to the develop and work from there. The way that we do that is, you would think, just type git revert and then put in the hash of that commit, but it's going to say the revert has failed because we didn't specify something very important, and that is what parent we want to actually revert from. So in other words, this merge commit right here has two parents. It has the develop branch parent and the feature 1 branch parent, since what we are basically doing at that commit is taking two branches and merging them back together. So we have to choose which one of these parents that we want to revert back to, and based on which one we choose, we'll see some different files in our working directory. To better see what was going on, let's first look at these two commits right here, the two that we actually merged together, and then we'll look at the actual merge commit to see the two parents that we're dealing with. So again, we're going to start with this one, and I'll use my pre-formatted command that we had typed in earlier. So right here, and I'll throw in that commit. You can see that the BOB9BCC hash is going to be the license edition. We can also see this in the diagram. So here's the license file that we committed, and then the JavaScript feature is the A505 commit. So we could also see that. Now let's take a look at this commit where we actually merged it together and figure out what the index of each of these parents are. Because our goal here is to actually delete the JavaScript feature out of our repository. You know, maybe it didn't work, it kind of messed things up, and we just don't want it anymore. So the way that we'll do that is by specifying the develop branch, which had the license file in it, as the parent for this merge. Or not the merge, the reversion. So in this case, we need to copy the commit hash for the merge commit and plug that into our pre-formatted command. And you'll see that we have two parent hashes. And reading left to right, we actually can add them together. So we have the index of this first one is 1, the index of the second one is 2. And if you had maybe 3 or 4 parents, which would be kind of unlikely, it would be 3 and 4. Now, you don't know what this means quite yet, but we'll use these indexes in the Git Revert commit itself. So let's remember we have the BOB one, which is going to be the license file or the develop branch, and then you have the the A505, which would be index number 2, and that was the JavaScript feature. So we don't really want to include that. So in other words, we're going to use the first parent hash, which is represented by index number 1. We're about ready to do this reversion. Let's look at our repo one more time. Remember, we're going to go back to this commit right here. That's the one we want to revert back to. And remember, we're not deleting anything here. We're just taking the snapshot at this given point in time and creating a new commit that reflects that. The tricky part is we need to tell Git which parent to use, and we had derived that we want the develop branch, and that is going to be index number 1. We'll say git revert, and then this is where we pass in the index, so to the main line, basically tells it what parent to use, and then finally you'll plug in the commit that you want to revert to. And you're going to see this nasty commit message. The reason being is because we have a merge conflict due to the fact that we had edited the index.html file in both the develop branch and the feature1 branch before that commit. So we need to resolve that really quickly. So all we need to do is open up Vim with the problem file, and you can see that it tells us right here with git status that we have an unmerged path for the index.html. So that's where I'm getting that, and we need to go into Vim, edit that. You'll see that the conflict is highlighted here with these two lines, and then finally this one. It says the merge branch feature1 into develop. That's where this conflict is coming from. And basically, you don't need to really worry about, what we're going to keep. We just need to fix it. So let's just delete these right here. And this is going to be the new state of our index.html file, which was the same state that we had prior to creating the feature branch. So we'll save and quit. We have resolved those conflicts. So now we can add index.html and commit it. So we'll say revert commit, resolve, merge conflicts. And we can now see what the repository looks like. And you'll see that we have this new commit here, which represents the state of the repository back at this commit without the feature1 branch integrated into it. So in other words, we have this brand new state of the repository while also keeping all the history of the repository. So this would be great if you actually had a feature that may have broken the repository, but you don't want to completely delete it in case someone was going to use it in the future, maybe reference back to it for learning purposes. I don't know. So that's the effectiveness of the Git Revert command. I know it's a little bit complex for this second example, but many times you're not going to have to deal with reverting back to a merge commit. I just wanted to show it to you in case that maybe you ran into that situation and you were like, what do I do? So hopefully that clears some things up and you won't be so nervous when it throws these nasty messages back at you when you try to revert. There's one more command that we'll look at, which is the Git Reset command. We'll do a quick review here because I think we've learned quite a lot in the last few minutes. First, just a quick review of the 4 states. Got to always keep that in mind because it's going to affect all 3 of these commands. So we first looked at the Git Checkout command, which essentially takes the head pointer and moves the head pointer to a different spot in the repository. This could either be a branch or an individual commit. And in order to do a Git Checkout, you'll need to be in state number 1. If you're not in state number 1, then it will ask you to either commit or stash your changes. We looked at how to stash changes, so you should be able to handle that. Nevertheless, always make sure you're in state number 1 before performing a Git Checkout. We also looked at a Git reversion, and we saw 2 examples of that. The first one was pretty simple. We just reverted back to the most previous commit. While the second one was a little bit more complex, where we reverted back to a merge commit. Now remember, with this revert command, what we're doing is we are going back to a point in time, so say the 6EFF commit, and we're taking the snapshot of the files at that commit and pulling those forward and replacing what is currently at the A9BCC60 commit, which is where the head and the master branch are pointing at the moment. So in effect, we move forward 1 commit in the repository, except we now are back at a previous state. We still have the history of everything that we've done. Now with the Git Reset command, we're going to be actually rewriting history in a sense. We're going to be completely deleting some of the commits that we have made, and depending on how you use it, you're going to have a slightly more dramatic effect. So I've put this Git Reset command out in this little circle matrix, whatever you want to call it, because each of the commands, each of the versions of the Git Reset command are going to successively do a little bit more. So in other words, if you ran the Git Reset Hard command, that's going to run the Git Reset Soft, the Git Reset Mixed, and finally the Git Reset Hard command all in one. If you do just the Git Reset Soft, it'll only do the Reset Soft. It won't do anything with the Mixed or Hard. So that's kind of how you should visualize this particular command. There's basically 3 different versions that you can use. Now we're going to start with the Git Reset Soft, but before doing so, we'll take a look at what this is going to do to our repository. So currently this is what our repository looks like. You can see that back in the terminal with the git log command, but this is a little bit more visual for you. And currently we are sitting at the 32C5025 with the develop branch, and 22DE28B with the master branch and the head pointer, which basically means that that's where, if we made changes to any files, that's where they would go, right there. Now the reset command, no matter what version of it you use, it's going to have the effect of moving both the head and the branch that the head points at back in time to a specific commit. In this case, I've shown an example where maybe we wanted to reset back to the commit 32C5025. And remember, this one right here, the 22DE, is our revert commit. And if we reset back to 32C5, that's actually going to reset it so much that we have the JavaScript feature back in our repo. Remember, the 22D commit, that's the revert commit, kind of took out the feature 1 where we added that JavaScript, but since that is only a reversion and we just basically took the state back here and pulled it forward, if we reset and moved all of this stuff back here, we're going to have that feature 1 branch integrated into our repository again. In effect, these 3 commits right here, the 6EF, A9B, and 22D, they're all going to just kind of float in space. And you'll see that once we have reset, we're going to have these commits somewhere out in space, but we have no way of referring to them, and therefore this command can actually get a little bit dangerous, because if you reset back to a place and then realize, oh wait, I wanted to go back, you can't really do so. Now, depending on which version of the command that you use, you may or may not delete the working directory. So in other words, if we use the Git Reset Soft command and then we come back to this state, we will still have the file changes that went into these commits. They'll just all be globbed together. Now if we use the Git Reset Hard version, we're going to basically delete everything out here. So anything that was added or removed or modified in any of these 3 commits out here, we're not going to have any recollection of, and we'll have 0 way of getting those back. So you do have to be careful with the Git Reset Hard command and even the soft and mixed commands. Alright, enough explanation. Let's get into actually writing some of the commands. As we run the 3 different versions of the Git Reset command, be aware of what state it puts us in. So at the moment, we are in state number 1, or at least we should be. I'll put this up on the screen for reference. We're in state number 1 where everything is synced up, but we'll keep a tab on which state we are moving to with each version of the Git Reset command, because that is ultimately the difference between each of the 3. So let me get back to the terminal. This is what our repository looks like right now. And given the fact that this command is pretty much permanent, we're not going to be too aggressive here. I only get 1 take with this, otherwise we have to redo the whole repository. So for this first reset, what we're going to do is essentially delete this reversion that we just did. So in other words, we want to reset back to the A9 BCC60 commit. And therefore, when we do that, we're going to if you remember, the revert commit basically took out feature 1 and therefore it took out the JavaScript files. So if we type ls, you're not going to see any sort of JavaScript here. And if we remove that revert commit or reset it, we should see all the feature 1 files. So let's do that right now. Reset and then soft. Make sure that you add the soft flag in. If you don't add a flag, it'll just default to the mixed version. And then finally, we will enter the commit that we want to go back to. So we are going to move the head and the master branch back to A9 BCC 6.0 with this command. And if we log out this repository again, you'll see that that revert commit that was at the top is completely gone. We have no recollection of that happening except for the staging area. So it'll show you that in the staging area we have a modified file, and that is going to be the changes that were made from that given revert commit. So if you remember, we kind of fixed the merge conflicts in the index.html. So that is going to be in the staging area after a git reset soft command. Now let's remember what state we are currently in. We should be in state number 3, which is basically the repository is not going to equal either the staging or working directory, but the staging area and the working directory are going to be equal. So that is what state we're in right now, and if we wanted to, we could commit and say add reversion files, and then basically what's going to happen here when we log out the repository, that's not the log command, there we go, is this is basically going to give us back our reversion, but it'll just have a different name. So as you see with the git reset soft command, we can recover the files that we kind of reset, but we can never get the exact commits that we had previously back. The same goes for the git reset mixed command, except this time instead of moving the head and whatever branch that points to back to a given commit and then staging the working directory in the staging area, what it's going to do is move it back and just leave the working directory. It's not going to add anything to the staging area. So we can do that real quick. We can just type git reset and then we'll go back to the A9 BCC 6.0 commit. And notice I'm not putting in any flags here because the mixed option is the default git reset option. And when we reset, it's going to say unstaged changes after the reset. And if we type git status, you'll see that we have changes not staged for commit, the index.html. And if you remember, the changes not staged for commit just represents the working directory, and therefore this state would be, I believe, number 4. So let's go back to our PowerPoint, and we are indeed in state number 4. The repository does not equal the staging area, which does not equal the working directory. Alright, so again, we can just add the index.html and recover the reversion once again. In this case, we have the same exact effect, and when we look at our repository, again, we have this commit that basically is recovering the reversion. Now, if we use the reset hard command, what it'll do is it will move the head and whatever that points to, whatever branch that points to, back to a given commit. It will then take all of the changes since that commit and delete them from the working directory, the staging area, and the repository. So in other words, we have no way to get them back. So let's run that real quick. Git reset hard, and then we will again go back to the A9 BCC 6.0. And right now, we have no way of recovering that index.html or whatever we changed about it. And if we log out the repository, you'll see that we pretty much don't have any recollection of the reversion that we did earlier. And if we type git status, it should be in state number 1 where everything is synced up. So that is the effect of the git reset hard command, and you'll actually see this. So say maybe we will just add a file here. So accidental file creation.txt. Maybe this was a file that we didn't mean to add in there, just got copied into our repository. And when we say git status, it will of course pick up on this. It'll figure out that there's something out there that we haven't quite added to the staging area yet. So it's in our working directory but not the staging area. And then it will basically say you need to add it, so we'll add that. And then when we type git status again, it'll say you can use the git reset head to unstage that. And so we could run git reset head to effectively use the git reset mixed command and go back to the most previous commit, or the commit that we're basically on, and that will in effect throw this file back in the working directory. So again, we run git status, it's back to our working directory. Let's just add it back one more time, and then this time if we run git reset hard head, then we are going to delete that file entirely. And when we type git status, everything's clean. When we print the contents of this directory, you won't see that file any longer. So that would be probably the most practical use of the git reset command, is when you're just want to kind of go back just a few steps in your workflow. But again, be very careful with it, especially when using the hard flag on there, because it can essentially delete a bunch of work that you did. So that is the git reset command in a nutshell, and all three of those commands, the checkout, revert, and reset commands. Hopefully you have a much better understanding of the differences between the three and have at least a general idea of when you might want to use them. So again, the git checkout command is when you want to just jump around in your repository. Maybe you're switching branches to work on a different branch. The revert command is if you want to kind of rewrite history without deleting anything in the history. So in other words, we go back to a snapshot and pull that forward in a new commit. So if we really wanted to, we could recover everything later. And then the reset command is if you want to just delete any commits in general. You can delete commits with the git reset command. To bring this discussion kind of full circle, we had talked about merge conflicts at the beginning, especially with pulling down from the remote repository to your local repository. But we never really talked about conflicts going the other way. So if we want to push upstream and we have some changes locally that we want to throw into the repository, we didn't talk about those type of conflicts. In most cases, you're not going to want to force anything when you're running the git push, origin master command. But in our case, we made a bunch of changes. We went back in time, deleted some commits, added some commits, and therefore the remote repository up on GitHub has no idea what's going on. So if we go back to my GitHub, and if we look at this repository, we've got a bunch of files here on the master branch. But if we come back to our terminal, you'll see that on the master branch, we're on the master right now, we don't have anything that even resembles that. So maybe we wanted to take, for whatever reason, we want to take the files here and push those up to the remote repository. Well, the only way that we'll be able to do that, and it's kind of a hacky way, again, this will overwrite a remote repository, and you need to use it with caution, especially if you're collaborating with others. But in our case, I'm just doing this alone, and I know that the local is the one that I want to throw up on GitHub. So rather than, going on GitHub, deleting everything and recloning and just kind of resetting the entire thing, we can just type git push force. So this will force the local changes to overwrite the remote changes, and then origin master. You'll see that we forced an update, and if we go back to the GitHub and refresh, you'll see that we have all of these files, and it now shows that there's only one contributor as opposed to 2 contributors before, so on and so forth. So that's how you would kind of fix a conflict going upstream, but again, be careful if you're working with other people. The Git source control tool can be super frustrating at times, especially when you're working in complex repositories with tons of branches and you're seeing a bunch of merge commits. Maybe you're checking out someone else's pull request and you need to figure out how to merge that into the master branch on the main repo. All of that kind of stuff can get very frustrating, but if you break it down into the basics and truly understand what's happening with all of these commands that you're running and take the time, this is probably the most important thing, you just take the time to think before you type commands, you should be just fine. Most of the time when people run into issues with Git, it is primarily because you're just typing a bunch of commands really quickly and you're not thinking about what the consequences of those commands are. And pretty soon you've run Git Reset too many times, you have no idea where all your commits went, and you're just hacking together something. So make sure that you really get these down. There's not a whole lot to actually learn with Git. It's really about mastering a small amount of commands that you'll be using over and over again. Hopefully this video, as well as my second video with the effective Git workflow, and maybe even if you're coming from the first video of Git basics, I hope all of these videos have kind of helped you get started with Git. Of course, they're not going to cover every situation, but they should get you 95% of the way there. If you liked this video, be sure to give it a thumbs up and consider subscribing. Thanks.